Hi friends, my name is Narasimha and I'm pursuing my engineering in IRA college. Today, as a part of my AIT concept videos, the subject of design and analysis of algorithms, I want to explain a topic named little o notation. So it is silent. So in our coding purpose or in a coding world, while we want to write an algorithm for getting a problem or for writing a source code to a problem, so the two main important things are the space complexity and the time complexity. So to measure the space complexity means the problem, the lines of kilos of lines of the code should be less and the time of execution of the problem should be less. Source code should be less. So while compromising or for satisfying these two factors, then only the algorithm will be a good one. So to measure the space complexity and time complexity, there are many vast methods, but to measure the time complexity, there are four methods such as big O notation or omega notation or theta omega or little o notation. In this lecture, we will know about what is little o notation, the derivation of it, and the uses of it. First of all, little o notation. Little o notation is an asymptotic notation. It is used to know about the time complexity of a problem. There are some other notations present except the, which I said before, big O notation, big omega or big theta notations, etc. The little o notation is one of them. Little o notation is used to describe an upper bound that cannot be tied. When there are two bonds, that is upper bound and lower bound, it will say about the describes about the upper bound that cannot be tied. In other words, it can be say that it explains about the loose upper bound of f of n, means a function. The derivation. The definition of a little o notation. Let f of n and g of n be functions that map positive integers to positive real numbers. We say that f of n is order of g of n or f of n belongs to order of small g of n. If for any real constants c greater than 0, there exists an integer constant n not greater than or equals to 0 such equals to 1 such that 0 less than or equals to f of n less than c into g of n. Here there are some more constraints or conditions. In this definition, first we have to assume f of n and g of n are both functions which are positive integers or positive real numbers, in such a way that f of n is order of g of n, or we can also say f of n belongs to order of g of n. For any real constant, that is sum of conditions, that is c greater than 0, there exists an integer constant n not greater than or equals to 1 such that 0 less than or equals to f of n less than c into g of n. Here this is a small diagram. Here we can see effort on the y-axis and on the x-axis, and omega, theta, f of n, big O of n, and small o of n. Here small o of n, which I was said before, it explains about the upper bound which cannot be tied. So the red line is specifying the small o of n, and f of n is a function which is a black line, and small big O of n, omega of n, and theta of n are specified in this manner. These are the four asymptotic conditions or functions which will say measure the time complexity of a problem. Next. Thus, little o means loose upper bound of f of n, which I said before. Little o is a rough estimate of maximum order of growth, whereas big O may be the actual order of growth. This is the difference between the little o and big O notations, that are big O notation be the actual order of growth, whereas little o is a rough estimate of the maximum order of growth, which is an approximate notation, which is not clearly mentioned. In mathematical relation, f of n belongs to or equals to order of g of n, which means that limit n extends to infinity, f of n by g of n is equals to 0. So this is a derivation of little o of n, which should be, when we are taken a problem and we have to measure the time complexity of that problem, it should be satisfy the conditions, and there should be two functions, that is f of n and g of n. Here is an example. Is 7n plus 8 belongs to order of n square. In order for that to be true, for any c we have to be able to find an n naught that makes f of n less than c into g of n, which I said before, asymptotically true. Let's took some example. If c is equals to 100, we check the inequality is clearly true. If C is equals to 1 by 100, we will have to use a little more imagination, but we will be able to find an N naught. From these examples, the conjecture appears to be correct. The check limits. Limit f of n by g of n is equals to limit 7n plus 8 by n square is equals to limit 7 by 2n is equals to 0, which is L'Hospital rule. N extends to infinity. Hence, by all these limits, if the following conditions, means the three conditions, c greater than 0 and n not greater than equals to 1 and 0 less than or equals to f of n less than c into g of n, 3 are satisfied, then we have to do the limit function, that is limit n extends to infinity f of n by g of n is equals to the two functions, f of n is equals to 7n plus 8 and g of n is equals to n square. So we have to substitute the values of c and n in this function and know that limit extends to infinity, n extends to infinity, 7n plus 8 by n square is equals to limit 7 by 2n, which is L'Hospital rule. And by doing this, we can get hence 7n plus 8 belongs to order of n square. So once again, recall all the information. Little o notation. The notation is an asymptotic notation. It will say about the time complexity of a problem. There are some other notations such as big O notation, big omega notation, big theta notations, etc. The little o notation is one of them. Little o notation is used to describe an upper bound that cannot be tied. In other words, loose upper bound of f of n. It's a definition. Once again, have a look about this graph. That is, here we want to know the function of f of n. This is a black line here. And the four other notations are red line indicating the little o notation, which are saying in this lecture. And here, L line representing the omega of n, here omega of n, theta of n, and here this is big O notation. Let's have a look about this. Next. This is a final mathematical relation, that is f of n is equals to order of g of n, means limit n extends to infinity, f of n by g of n is equals to 0. This is a final solution. If in the problem all the solutions are being satisfied, then we will move to the final solution, that is limit n extends to infinity, f of n by g of n is equals to 0, by which we can get the final output, whether the time complexity satisfying the order of n or order of n square or order of 1. Order of 1 is the best. Next. So I want to explain clearly this example. 7n plus 8 is a statement. So by executing this statement, will the time complexity will be order of n square or not? Is a question given to us. So by using this little o notation, we want to say this is correct assumption or not. So in order for that to be true, means for being that assumption is to be true or false, for any c is a variable, we have to assume, because the c should be greater than or equals to 0. We have to be able to find that n naught is greater than or equals to 1. That makes f of n less than c into g of n, asymptotically true. So first we have to get c value, next is the n naught value. C should be greater than 0, n naught is greater than or equals to 1. So, and finally, the value should be in such a manner or such a way that f of n less than c into g of n. When substitute the c values and n values, that should be equate this condition, asymptotically true. Let's take some example. Let's take c is equals to 100, 50, 45, 55, anything, and n naught value also. Both should satisfy the above condition, that is f of n less than c into g of n. From these examples, the conjecture appears to be correct. Then check. Means if the c values and n values are satisfying that f of n less than c into g of n, then check the limits. That is, limit n extends to infinity, f of n by g of n is equals to limit 7n plus 8 by n square. Substitute the n values in this and you will get limit 7 by n to n, that is by following the L'Hospital rule. Hence 7n plus 8 belongs to order of n square. So, which I have said before, while we consider any algorithm, it should satisfy the space complexity and time complexity. So, without satisfying the space complexity, for example, we are taking an algorithm of finding the factorial of a number. There are many ways for finding the factorial of a number. So, if it is very large problem and it is not satisfying the space complexity, means the kilos of code, means the lines of code are very vast. So, by that, the space complexity, means that device or the allocation of space to a variable will be very large. Unnecessarily, if you take many variables in the condition or the source code, it will result in the wastage of a space. And if we take unnecessary loops like for loop or while loop or do while loop, if we take unnecessary loops, if loop else if else conditions or if else conditions, nested if conditions, it will result in more time complexity. So which will result in more execution of a time of a code, and which will also result in more usage of the data. So while we are writing an algorithm or while we are writing an source code, the main two important things which we should remember is it should reduce the space complexity and it should reduce the time complexity. So by reduction of these two properties, then only we can get the proper and very valuable code by which we can get a proper output. So in this, we can get two of the ways. We have to measure the space complexity by in their methods called to measure the space complexity. We have to measure the amount of space required by a variable, that is 2 bytes or 4 bytes, depending on the data type of the variable. That is, it is an int or long int or anything, etc. So by adding up all the spaces or used by the variables, we can get the space complexity, by which we can know that whether the code is useful or suitable for getting the to reduce the space complexity or not. In the same manner, to measure the time complexity of a problem, there are many ways such as big O notation. These are all the asymptotic notations, little o notation, omega notation, and theta notation, based on the upper bounds or the lower bounds. For example, if we have to find a loose upper bound notation, where preferable notation is little o notation, which I said before in this lecture. So to measure the time complexity, there are 4 notations. So by this help of the notation based on the conditions, we can get the time complexity of an algorithm, by which we can say that the algorithm is useful for us or not. So this is an example, and thank you friends for watching my video, and I think this lecture is useful for you. Thank you.